So hello once again, we are now back with our subject that is forensic chemistry and toxicology. So we are now moving on chapter 6 and chapter 7. So chapter 6 talks about the glass and chapter 7 talks about the casting and latch. So for the importance of glass, it is of course very used or widely used as pieces of evidence when we are talking about robbery and hit and run cases. So when it comes to robbery, of course, we all know that in the criminal law, there is now a distinction when it comes to theft and robbery, in which in robbery there is now evidence that will prove, or there should be a requisite or element that it will now show that there is a forcible entry upon the premises or upon the things, or yes, upon the premises that is now subject for stealing incident. So course, in order to prove that there is a forcible entry, especially the most common entry point in when it comes to robbery cases or when it comes to stealing incident, that is on the windows or any point that is very soft, or any place on the house or any place on the premises in which that is soft or easy access, or there is just the use of minimal force in order to enter the premises. So of course common, that is windows or doors that will now be destroyed or break by the intruders in order to have access to the premises. So in order to prove that there is no forcible entry when the entry point or egress on the property or in the subject to stealing incident is windows. So we are now going to analyze the windows or the glass composition of window in order to determine if there is no forcible entry on the premises, or it is just a normal breakage that is caused by wind, that is caused by stone or other factors. So when it comes to motor vehicle incident or hit and run cases, of course, we can examine the glasses that is present on the area. And of course, if the vehicle is retrieved, we can also examine the glasses of the vehicle in order to examine the components if it will now match in the glasses that is that live or that is present or that is lived by the vehicle when the vehicle is now running from his or her victim. For the definition of glass, it refers to a supercooled liquid which possesses high viscosity and rigidity. It is a non-crystalline inorganic substance. So we all know that before glass is made, there are different ingredients, or there are different uh, chemicals that we're going to mix in order to create glass. And of course, glass in its first state or starting state is it is in liquid state, in which it will now shape by the workers in order to fit with their shape or sizes that is the customer is now demanding. And after that, it will be super dry, or it will be cooled using air, or either different cooling devices in order for it to become durable and in order for it to become solid. Or the different oxide that is added to glass in order to, it's either add durability, it's either to add rigidity. So there are six in this table. So silica, commonly silica is added in order to uh, or it is commonly used for commercial purposes only. So the glasses that is present on your houses, on business establishment, or yes, business establishment. Commonly, those windows are made up of silica. So silica is the most weakest type of oxide that is used in glasses. That's why glasses in our houses on our in the establishment, building establishment is very fragile. When it comes to soda, it is added in order to add up durability if silica is added. For lime, it is added in order to add durability in the glass. So from silica, if we are going to add silica on glass, it is fragile. But if we are going to add lime, it will add up a small amount or a small degree of durability on glasses, although it is still fragile. Next, we have magnesis. When it comes to magnesis, is this just a uh, what we call the substitute for lime. If there is the absence of lime, magnesis will now be added. So the same, it will add up a small amount of durability on glasses. For alumina, it will, of course, add up some greater amount of durability. So commonly, those glasses that is present on the shelves of those person who are selling jewelries or expensive things that is now displayed on a it's either cabinet or places that is places that is the what you call that the thing that is selling is flash on the glasses. So commonly those glass is made up of alumina. So those glasses is not easy to break. You need to exert extra amount of force, or you need to use special equipments or hard object in order to break this glass. If the oxide that is used is alumina. And lastly, that is now the potash. Potash is the most used oxide in order to add greater durability of glasses. So commonly, potash is added for those glasses that is made up of bulletproof glasses, or in order to add greater amount of durability on glasses, potash is added. For the analysis of glass, so the common test or analysis that is used by chemists, there are six. We have spectrographic test, we have X-ray diffraction test, we have physical properties examination, ultraviolet properties examination, and we have polish mark test. For the spectrographic test, the specimen is analyzed to determine if there is to determine the presence or trace of the elements that made up or constitute this glass. So the beauty of this test is there is no need for you to have a lot of pieces of evidence or sample evidence in order for it to examine. So minimal amount of glasses is enough for it to be analyzed. For X-ray diffraction test, it is not effective compared to spectrographic analysis, because in spectrographic analysis this the spectrographic test will now determine what composition or what are the composition of this glass, including the impurity that is present on the glass. But when it comes to X-ray diffraction test, it only determines the pattern of glasses. So there are different patterns on glasses when we are talking about the different companies that is creating glasses. So there are different patterns in which they will now differ from one another. So that is the only thing that will examine by X-ray diffraction test, compared to spectrographic test that it will analyze the chemical component of this glass, including its impurities. For physical properties examination, so commonly this is the best and the most sensitive method in determining the difference of the composition of glasses. Commonly, it is the same with the spectrographic test, but there are different methods in order for physical properties examination should be done. So commonly, uh, the glass sample and or depends upon the study of physical properties of glass. So properties like specific gravity and then density refractive index is the common uh, thing that will now be that will analyzed by this physical properties examination. So commonly there are two: the specific gravity and density. So if we are talking about flotation method, it is now being done in order to determine the density of the glasses. If you are talking about the immersion method, we are now going to study the refractive index of glasses. If you're talking about the refractive index of glasses, that is the uh, mechanism or properties of glass in which it will now refract the light that is passing through it. So that is what we call the reflective index of glasses. So we study it in forensic photography, the natin dito, the travel of light. So there are reflection, refraction, and so on and so forth. So refractive index is the same in the photograph, in the discussion in photography, in the refraction of light. So the manner on how the glass will refract the lights that is passing through it, that is what we call the refractive index. So don't forget, if we are talking about flotation method, we are talking about the study or the method in order to determine the density of the glass, while a immersion method, we are going to analyze the refractive index of the glasses. For ultraviolet light, simple, it only determines the difference of the appearance of the glass when it is examined through the use of fluorescent, in which it will now indicate the physical and chemical differences of these glasses. For the polish marks, commonly, uh, what we call that, glasses is polished in order to avoid cutting the hands or in order to avoid accident if the person who are holding this hand will now use his or her bare hand. So in order to avoid those cut that is made by the sharp edge of the glass, there is a need to polish it. So the thing that is going to examine by this polish mark is to identify the polishing method that is used in these classes. So commonly it different from other glass to others. So it is a basis in order for it to be compared from one another. For glass as an evidence on the crime scene, so in the field of forensic chemistry, it emphasizes on automobile glass. For automobiles, of course, the glass is present on automobiles when it comes to hit and run cases. When it comes to robbery, of course, if there is a broken window, it will now determine if there is forcible entry upon the building or premises. And of course, there is a broken bottles, ringing glasses, and other glasses that is present on the crime scene. So when it comes to analysis of glass, when it comes to vehicular accident, the analysis or test that we'll be going to utilize is the thing that is discussed a while ago, the 6 tests that is commonly used by chemists in order to examine glasses. For analysis of broken windows, of course, there are two things. There are two things that we are going to analyze: the glasses that is present at the crime scene and the glasses that is present on the suspect or the perpetrator. So it will going to match. It will going to analyze by the different analysis or techniques or tests that is going to determine the composition of glasses and its impurities. So if match, of course, it positive, or it is a corroborative evidence in which the glasses that is present at the crime scene is present on the vehicle or on your possession. So that is just a corroborative evidence that it's either you or the perpetrator, it's either your vehicle is the one that hit the target or the victim, I should say, or in robbery cases, there is now glass that is deposited on the pocket or on the clothing of the perpetrator, in which later on, when this perpetrator is arrested, the traces of glasses is recovered on his clothing. So there is now a thorough examination by the chemist, and they will now analyze it if the physical properties or the chemical properties of this glass and its impurities is the same from the collected on the crime scene and collected from the perpetrator or suspect. For the same, from when it comes to the broken window that is caused by bullet, number one, or the most thing that is being examined when we are talking about the windows that is it's either uh, break or destroyed by bullet, we are going to analyze its flakes or the little or small cracks that is deposited on the glasses. So we can determine the angle, we can determine the range of the shooter, and so on and so forth. So a little bit um, info or information that if the shot was fired on an angle from the right side, or if it is shot on the left side, we can immediately determine if it's shot from left or right angle. So if there is excessive flakings, is either on the right side or on the left side, we can immediately, if the bullet comes from right or left. So, for example, if the flakings came from the right side, there is a what we call that a small breakage on the right side of the window. Commonly, the perpetrator comes from the left. So there is flakings on the right side. There is a small breakage on the panels or glass panels. So commonly, the assailant or the person who shoot the firearm comes from the left side or left side angle. For broken window caused by fist or stone, of course, there is just a what we call unique shape that is caused by fist or stone if there is now glass that is destroyed or broken. So there is just a small crack or there is the different parts when we are going to examine the glasses. So commonly, there are different principles or things that you are going to take note if you are going to analyze the break in the glasses. So we have the principle of 3R rule in the radial fracture. So in 3R rule, it states that stress line in the radial crack will at right angle to the rear or of the glass. When it comes to the principle of the RFC rule for concentric, or we are talking about RFC, that is rule for radial crack. If we are talking about the concentric, a while ago we are talking about the radial crack. Now we are talking about the concentric crack. So it states that stress line on concentric crack will be at right angle in the front side. So for your basis, if what we are talking about the concentric and what we are talking about the radial fracture, so that is now the difference of concentric and radial fracture. So if that is a straight line, commonly that is from the center of impact, that is point of impact, there is now is either a line, a straight line that is distributing on the different parts of the glass. That is what we call the radial fracture. So if there is a bow-like appearance on the glass bow, it's either letter C or bow, commonly those cracks are classified or characterized as concentric fractures. So that is the 3R rules when we are going to consider radial fracture and concentric fracture. So that is a straight line. It doesn't mean a straight line as long as there is a line doesn't mean it is straight. That is what we call radial fracture. If there is a bow or letter C appearance on the glass that's break, so commonly that is concentric fracture. So we are done when we are talking about chapter 6 of our handout. So commonly that's very that is not too long. It is a short topic. So commonly, if that is a face-to-face um, meeting, we are going to have a laboratory activity in which you are going to break a glass, you're going to identify the point of impact, the radial fracture, the concentric fracture, and you are going to determine if it is caused by hammer or any instrument, if caused by fist, bullet, and so on and so forth. But it's not face to face, so maybe we can do it if we are now going back to normal. Next, for foot impression or tool impression, so the same. It is not as best as blood, DNA, or hair, but still it can be used as a corroborative evidence in order to free innocent and convict those perpetrators. So, for traces that is left only if that the area in which the crime that is perpetrated, the there is soil, so it is not concrete. The perpetrator stepped on it, and there is no trace left on the crime scene. So, as a general rule, we can preserve that footprint. We can preserve that marks or other tool marks by using photography. But the question is, the photography cannot preserve the whole appearance of the evidence because the photography cannot determine what is the appearance when we are going to look downwards. If we are going to look on the left or on the right, we can only determine or we can only appreciate it looking it on the portion in which the camera photograph it. So it is very important in order for it to have it cast, in order to have a 3D impression on it, in order to determine the specific markings on the sole, the specific marking on the shoes or on the tools, in order to determine or we can compare it if the perpetrator is arrested and the things that is used or the shoes that is used in the commission of crime is in his possession. That is now a corroborative evidence that the shoes or the markings on the crime scene and the shoes that he possessed match from one another. So corroborative that he is present on the time when the crime was committed, because how come that the footprint that is lifted on the crime scene is the same on the shoes that he is using or she is using? So for the term that is impression, or for the term that we are talking about that is impression, so commonly that is a strong mark uh, that is produced by pressure. So it is embedded. So commonly, it is noticeable by our naked eye. When it comes to imprint, that is only a weak mark. So commonly, we can determine it, but we cannot determine the other characteristics of it. So that is just the comparison of impression and imprint. So impression strong force that is produced by pressure, in which we can easily determine it or we can easily examine it using our naked eye, while imprint that is weak mark that caused by pressure, in which we can examine it through our naked eye, but there are things that is lacking on it. Next, we have moulage. Moulage is the reproduction of an impression with the use of casting material. So the common casting material that we are using is the plaster of Paris. Plaster of Paris is the same as the instrument, or that is just a thing or a powder that is used by doctors or by used by the dentist in order to fix the fractured bones. We have the casting material, any material which can change from plastic or liquid state to solid conditions. And that is now the characteristics of casting material. From its state, from powder, you are going to add water and other chemicals in order to add durability, in order to add uh, what we call stability on the chemicals on it. And later on, when you are going to put it on your subject or on your specimen, while waiting, it will now turn into solid. So from liquid, it's either from liquid, from plastic, it will now turn into solid condition. So that is what we call casting material. So the common, just like I said a while ago, the common casting material that is utilized is plaster of Paris. Next, for other definition or for the things that is added to plaster of Paris in order to have different action. Number one, hasten. If you're talking about hasten in order to rapid or in order to fast forward, it's what you call that? From liquid, it will be going to solid. If you are not going to add up hastening material, you will wait for an hour, 2 hours, or 3 hours, more than 3 hours in order for the plaster of Paris to become solid. But if you will adding up this uh, hastening chemicals or hastening properties in the plaster of Paris, you will arrive desirable stiffness or solidification of plaster of Paris if you are going to add this kind of chemicals. So commonly, you are going to add salt or table salt on plaster of Paris in order to hasten the transition from liquid to solid. So you will not wait for an hour in order for it to solidify. So you will just wait for 30 minutes, 40 minutes, and it will now solidify because you add up a hastening devices or hastening chemical uh, in order to rapid, in order to hasten now the transition from liquid to solid. So the most common hastening chemicals or hastening device that we are using is table salt lang naman. For retarding, that is to improve the reaction of plaster of Paris when we are now going to use it in this specimen. Commonly, the thing that is going to add is, of course, borax. At the same time, 10 parts of water to plaster of Paris. Next, hardening in order to secure the stiffness or in order to uh, secure the durability of the cast that you are going to what you call that you are going to create. There is a need for you to add up hardening chemical. So the common thing that you are going to use in order for it to, of course, have its durability, of course, is the sodium bicarbonate, or what we are calling talcum powder. For the drawback of plaster of Paris, there are times that if you are going to use plaster of Paris, the durability is not present, or the durability of the plaster of Paris is not secure. So commonly, if you have put cast on the print, and if you are going to lift the plaster of Paris, immediately it will break into pieces. So that is the thing that we doesn't want to happen if you are going to cast uh, plaster of Paris, or we are going to provide 3D impression of the prints that is present on the crime scene, because it will totally destroy the pieces of evidence. So this is just an example of the casting knowledge that we are talking. So there is a print on the sand. Commonly, that is left by the perpetrator. We are now going to add the plaster of Paris. That is, of course, there is now the hastening, the retarding, and other chemical that is added in order to secure durability, in order to secure the chemical work of this plaster of Paris, in order to secure now that this cast will immediately solidify for a span of minutes. So after that, of course, when the plaster of Paris from liquid turns into solid, so that is now the 3D impression of the sole of the shoes that is present on the crime scene. So we can easily examine what are the traces, what are the trademark of the shoes, and later on, if the police officer is conducting follow-up investigation and there is a shoes collected in the possession of the suspect, and of course they can match it, they can examine it and match it if these shoes is the same on the print that is left on the crime scene. So aside from plaster of Paris, there are other casting materials that is that is being utilized. So we have wood metals. So wood metals is used for small impressions. We have tooth impression, tool impressions. So commonly wood metals, its composition is we have. Oh, I forgot the names of the elements. So we have I don't PB, plumbum. Lead, I don't know if PB is lead. We have SN, CD. So that is just your assignments to determine what is those elements that is present on wood metal. So I'm so sorry. I forgot those element is flashing on the PowerPoint presentation. So commonly that is the composition of a wood metal that is commonly used for casting materials. For plastic material, so that is a plasticine for dental composition used for small impression. Dental composition is the best casting material for making the cast or tool marks. So the drawback is distort when removed from impression since plastic does not flow to the very intense size of the impression. So commonly that is the problem if you are going to use plastic cast material. It will not go into the specific or small part of the impression in which it will not really save or it will now really copy the what you call the marks that is embedded on the soil. So commonly, plastic material is not really used as casting materials as well as wood metals. We have negocol. So negocol is commonly used for human body. So if your face is fractured, so commonly they will place negocol on your face in order to secure or in order to for your bones to secure in order to avoid it to have fracture again or in order to avoid it to be break again. Next is cellaret. So cellaret is the same when it comes to negocol, but the color or the appearance of cellaret is not the same when it comes to negocol. So cellaret is just a brown substance used for backing and strengthening. So commonly it is just an additives in order to add durability on the cast materials. So for cast of the human body, so commonly yes, we are using it just like what I said a while ago that if you have fracture on your hand or on your shoulder, commonly they will place cast on it in order to avoid it for to be break again. So commonly uh, casting materials is also utilized for the human body in order for it to secure the healing of our bones and of course to avoid the breaking or re-breaking of the bones that is fractured. So that's all for the discussion or no, we have still topic pala. So we discussed a while ago the casting material. So now we are talking about the tool impression. So a while ago, we talked about uh, footprints or we talk about other prints that is not considered tools. So commonly, for tool impressions, there are two things you are going to take note if you are going to analyze the impression. So number one, those produced by such instrument like axe, hammer, plier, and cutter, which touch the area only once and producing impression. So we are talking about the impression that is only embedded once. So for compression marks, it is produced by single application of tools on the area. So commonly, you hammered it once. So those classification will fall under compression marks. You use axe, you hit it once. So commonly we call it as compression marks. If you're talking about friction marks, these are series of scratches or striation produced by pushing of tools across the surface of those produced cutter, axe, or jimmy. So for cutter, you're going to slice it, another one, another one. So we are talking about friction marks. You slice or you embed the tool marks not once, but you commonly repeat it many times. So that is what we call friction marks. The other one is those produced by instrument like saw. that is applied in repeated stroke over the same area. So commonly there is a saw, chainsaw. You are going to, what we call that, you are going to break or you are going to separate wood, you are going to chop it into pieces, so you are going to saw it many times. So that is the number two that we are talking. That the impression, it is not strike many times, but it is strike 1,000 times. So there is just two things in order to consider. If it is the tool mark strike once, you can analyze it very easy. But if you use tools that commonly touches the material many times or 1,000 times, commonly you need a special technique in order for it to be analyzed. So that's all. So what is the importance of studying tool impression? So specifically, if the use or the weapon used in the commission of the crime are tools, it's either shovel, it's either hammer. So those impression will now determine, or it will be used as a comparison if the impression that is embedded by this tool is the same on the pieces of evidence that is collected on the perpetrator. So that is the importance of studying tool impressions. So far, that's all for today. And I am uh, making a video presentation again for chapter 8 and chapter 9 because on December 11 will be the last day of our class, so we need to cover time. So that's all for today, and thank you.